Hi-10 was founded in 1958 and in the last 50-odd years we've become one of the largest suppliers of reinforcement in the British Isles with 6 manufacturing centres and an annual turnover of currently around 45 million. Bamtech is a global product, manufactured under licence in 17 countries around the world. Hi-10 became the licensee for the British Isles in 1998, and since then it's grown into a very important part of our business, and we think it's going to carry on growing in the future, and we're committed to making sure that we can meet that demand.
Bamtech's been in the UK for the last 6 or 7 years, but it was developed in Germany some 10 years ago. This is the cutting edge of reinforcement technology.
We could actually lay down 25 tonne of Bamtech in 2 hours.
The rolling out of the carpet is far faster than traditional fixing of loose cut and bent bar.
We've got a pour today which is about 140 metres cubed. That was prepared in 2 or 3 days, whereas previously that would have taken us up to a week.
If you can save 1 day per floor on a 20-storey building, it means you're saving 4 weeks overall on your programme.
You can't allow for the fact of windy days, rainy days, but at least with Bamtech, you know in 2 days you can get a pour.
It gives us an edge, it gives us certainty.
On the big jobs, it's the big winner, it's got to be.
It's more than just a product, it's a complete design service from start to finish.
The Bamtech system is a fully integrated process, from design and detailing to manufacture and installation. The first step is design. Hi-10 can design the slab reinforcement using powerful finite element software, which fully optimises the reinforcement so that the slab contains the minimum amount of steel possible. Alternatively, an engineer can send slab reinforcement designs to be imported into Hi-10's software. The software automatically details the reinforcement, precisely matching the bars to the loadings specified by the slab design. Once the design and detailing have been checked and approved, schedules are transferred electronically to one of Hi-10's Bamtech manufacturing robots. The robot automatically selects bars of the required diameter and measures and cuts them exactly according to the configuration required by the engineer. The bars are then welded in sequence to thin metal tapes, and the resulting carpet is rolled up as it is pieced together by the machine. Reusable helicals are fixed at the centre of each carpet to facilitate transport and handling. Bars within each carpet can be different diameters from 8mm to 32mm, at different centres and of differing lengths, allowing the carpet to fit the slab precisely and to cope efficiently with varying load requirements. Carpets can be created up to 15 metres wide and 30 metres long. Once completed, carpets are easily lifted and transported from the manufacturing centre to the site. Once on site, layout drawings indicate precisely where the carpet should be placed. The Bamtech solution consists of 4 layers of steel, 2 layers of bottom steel laid at right angles to each other, and 2 layers of top steel, also laid at right angles to each other. The bottom steel is supported on spacers to suit the concrete cover required. The top steel is then laid on continuous wire-high chairs to suit the top cover required. Once all the reinforcement has been laid, the concrete can be poured.
Bamtech allows the customer, through finite element analysis, to reduce the amount of steel that would normally be put into a flat slab using cut and bent reinforcement.
All we need to do is to supply the performance specification and the loadings to Bamtech. They produced all of the drawings and details and calculations, sent it back to us. We checked and made sure that it complied with our requirements and approved it. This ensures two things. Firstly, that we optimise the slab thickness and make sure we get the thinnest possible slab. It also optimises the curtailment of the reinforcement and gives an advantage on the overall steel tonnage.
It's also extremely fast to lay, and that's the main benefit that the contractor on site will retrieve, in as much as the rolling out of the carpet is far faster than traditional fixing of loose cut and bent bar.
The product is dearer in terms of its base material costs, but it enables you to actually move your floors quicker.
The speed of the construction, actually laying it and getting your cycles faster, are a lot better for us.
This way you just have the big roll and you get it in place all in one go. You could lay an area in probably 2 or 3 times as quick as loose steel.
We could actually lay down 25 tonne of Bamtech in 2 hours, and we could probably lay 50 tonne in a day and a pour would be ready.
It gives you programme security, because you can't allow for the fact of windy days, rainy days, but at least with Bamtech, you know in 2 days you can get a pour. So it does give you comfort.
It gives us certainty, and with that certainty we have got less risk and we are more confident with taking those ambitious projects.
And there seems to be far fewer steel fixers than you would have on a normal job.
The detailing of the drawings means that you're not standing over the job too long. You just basically look at a mat on the drawing and drop it down and roll it out.
There is a scarcity of labour, there's a scarcity of steel fixers, so we've got to use that resource much better than we are at the moment. This product enables us to do that.
When you're rolling Bamtech, you just push it. It isn't so laborious. It isn't so difficult.
Laying a reinforcement is such a hard job and your back's bent all day. With the Bamtech, you don't get that. You just lay it down, roll it out.
The HSE are really tight these days in terms of manual handling, as there should be with a number of back injuries which are caused on site, and Bamtech can really help you with that because you haven't got guys lifting loose bar all day.
The health and safety executive appear to like this system because there's less repetitive strain injury. They think it's reduced repetitive strain by about 80%.
Basically, we see it that you can probably use the material, the Bamtech process, in any area or any instance where you have a flat surface which needs to be reinforced. We seem to be able to use it in any type of shape of floor plate. It doesn't have to be rectangular. There's one building we're looking at the moment is actually circular, and we're using it quite successfully. We find it quite flexible, remarkably so. In fact, when you consider that you come to site with a big roll, everyone thinks it's just going to get in the way, but we find it quite adaptable.
Basically replacing the Manchester Children's Hospital and the other couple of hospitals next door to it to form one big hospital in the centre of Manchester.
One of the major problems in hospitals is the requirement for operating theatres, which have very stringent requirements for vibration, and by using flat slab construction we could meet those requirements.
This particular building is worth £240 million. Should be complete the end of 2010.
It's a multi-million-pound contract for Hero Construction. It's reinforced concrete columns and slabs, and it's on various levels from ground to some areas 7 floors.
The overall contract value to us in this first phase is 12 million. The overall projected value for our works alone is probably mid-30s. So it's a very big part of our business.
There's something like 3,000 tonnes of Bamtech to go down here over the next year or so. It's been a very, very good project for both High 10 and hay rod, in as much as the project is ideally suited to the use of Bamtech with very large rolls, giving hay rod the maximum advantage in fixing speed and time savings.
What McDonald have actually designed all of the slabs themselves using finite element analysis, and then Bamtech have used our basic layout drawings and produced detailed drawings based upon those which have been used in the construction process.
We're delivering an integrated system where we've taken a design from the engineer and converted that into the best possible use of steel in the slab.
The benefit of this product is that clearly it's not as dependent on labour, which is a scarce resource in today's market, but it does give a quicker rollout system in terms of laying, of course. There are other benefits in terms of health and safety.
This is the first project I've been on where they've actually used this system. It works well, and there seems to be far fewer steel fixes than you would have on a normal job.
We can get the Bamtech here and get a slab down within 2 or 3 days really, as opposed to normally probably 4 or 5 days with ordinary loose fix.
Whilst the product is dearer in terms of its base material costs, there are clearly benefits in reduction of the overall labour values and costs associated with it that enables you to actually move your floors quicker.
The speed of the construction, actually laying it and getting cycles faster are a lot better for us, and the detailing of the drawings means that you're not standing over the job too long. You just basically look at a mat on the drawing and drop it down and roll it out.
You could lay an area in probably 2 or 3 times as quick as loose steel, and you don't have the problem of looking for loose steel and finding it out of a bundle and getting a few bars up at a time. This way you just have the big roll and you get it in place all in one go.
The use of Bamtech here is really giving hay rod an advantage in cycle time and to help ensure that they finish the job on programme.
We're here at Addenbrooke's Hospital in Cambridge, and the project is the NHS and SIDEM research block for genetic research into diabetes. The project for McDermott's is worth approximately £8 million. We started in earnest in January, and it's a substructure and superstructure package. We're pouring currently 2,500 cubic metres per month, and we hope to be finished in another 4 weeks' time with 5 suspended levels on the SIDEM block and 6 suspended levels on the NHS block. One pour takes 3 days to produce the formwork, and similarly then the Bamtech takes about a day and a half, and then we pour the concrete. The cycle we're retrieving is from pour to pour 3 weeks.
I've used Bamtech on 2 occasions now, both in PFI jobs, the hospital jobs. One in Roehampton, Queen Mary's Hospital for Bovis, Lend-Lease, and again here for Alfred McAlpine. Both times McDermott's have given the option to use it and explained the value of Bamtech to big jobs like this.
There's 2 main advantages. One is it requires less skilled labour. It also gives you programme security, because you can't allow for the fact of windy days, rainy days, but at least with Bamtech, you know in 2 days you can get a pour. So it does give you comfort, but of course it does save you. It saves you in labour, and it does save you in time.
Put it this way, if I could, I wouldn't use any other system.
On the big jobs, it's the big winner. It's got to be.
We've been established since just after the Second World War. We've been about for nearly 60 years now. We do a wide range of consulting projects. A lot of our work at the moment, perhaps more than 50%, as you might expect, is in high-rise residential. A lot of it in fairly compact city centre locations. Most of it reinforced concrete. At the moment, we're working on a project at Commercial Street in Manchester. It consists of about 260 residential apartments with commercial units at the bottom. It has a 2-storey basement. It's quite a representative project because we're using Bamtech in 2 different ways. There's basically 2 different blocks, one of which we've designed as a rigid frame. We designed the floor plates, indicated the densities of reinforcement, passed it on to Bamtech, who then translated that into the Bamtech product, sent it back to us for checking and approval. The other block was of a fairly similar size. All we need to do is to supply the performance specification and the loadings to Bamtech. They produced all of the drawings and details and calculations, sent it back to us. We checked and made sure that it complied with our requirements and approved it. The analysis of all of the floor plates using up-to-date finite element analysis packages. This ensures 2 things. Firstly, that we optimise the slab thickness and make sure we get the thinnest possible slab. It also optimises the curtailment of the reinforcement and gives an advantage on the overall steel tonnage. A lot of the city centre sites we're working on have very tight site areas available. Very limited areas to lay down reinforcement materials when they arrive on site. The Bamtech rolls being assembled the way they are, it's having lifted up onto the tables, it takes 2 people to actually roll out the mats. And it's quite easy to set the mats up, so we find that the actual time spent placing the reinforcement, not only does it require less labour, but it can also be done faster as well. It's very important, even if you can save 1 day per floor in a 20-storey high building, it gives you a 4-week advantage in the overall programme. We're constantly learning, but basically we see it that you can probably use the material, the Bamtech process, in any area or any instance where you have a flat surface which needs to be reinforced. We seem to be able to use it in any type of shape of floor plate. It doesn't have to be rectangular. There's one building we're looking at the moment is actually circular, and we're using it quite successfully. So we find it quite flexible, remarkably so. In fact, when you consider that you come to site with a big roll, everyone thinks it's just going to get in the way, but we find it quite adaptable. So that's the future for us, hopefully for many years to come.